As humanity peers into the vast expanses of space, we are confronted by a universe that is dynamic and ever-changing. Astronomers and astrophysicists have long marveled at the majesty of the night sky, which seems, on the surface, to offer a steady and predictable map of stars, galaxies, and nebulae. However, the cosmos is far from static. Beneath its apparent calm lies a turbulent and rapidly evolving reality. The fabric of spacetime itself is constantly in flux, and we are witnessing changes in our cosmic neighborhood at a pace that is faster than we once imagined. Some fear that this acceleration may soon lead to a dramatic shift in how we perceive the night sky, a prospect that leaves many, including experts, uneasy. The night sky, our cosmic backdrop, has served as a navigational tool and a source of wonder for millennia. It has remained largely recognizable, with familiar constellations and celestial bodies acting as beacons for explorers and astronomers alike. However, this comforting stability may be on the verge of disruption. Astronomers worldwide have begun sounding the alarm about imminent changes to some of the most iconic stars in our sky, and one star in particular, the famous Polaris, or the North Star, stands at the center of this growing concern. Polaris, long celebrated for its unwavering position in the northern sky, has been a trusted guide for seafarers, travelers, and astronomers for centuries. Its proximity to the celestial North Pole means that it appears almost stationary from our vantage point on Earth, a rare trait that has made it indispensable for celestial navigation. But recent research indicates that this anchor of the night sky may soon undergo a transformation that could alter its place in both scientific and cultural history forever. The warning signs have been mounting. Astronomers, including prominent voices like Neil deGrasse Tyson, have pointed to irregularities in Polaris's behavior that suggest it is approaching a significant and potentially catastrophic change. Tyson and others have noted that Polaris's pulsation patterns, its regular brightening and dimming, have deviated from their long-established norms. While such variations are not unusual for certain types of stars, the specific changes in Polaris are causing scientists to take a closer look. Could we be on the brink of losing the North Star as we know it? The possibility has ignited discussions and debates in both scientific and public circles. In September 2023, a research paper presented by the Royal Astronomical Society fueled these concerns. The paper detailed findings that cast doubt on the future of Polaris, suggesting that the star is nearing the end of its life cycle. While Polaris's ultimate fate remains uncertain, some astronomers believe it could be on the verge of a dramatic event, possibly even a supernova explosion that would forever alter the appearance of the night sky. To fully appreciate the implications of this potential event, it is crucial to understand the nature of Polaris and its significance. Polaris, often referred to as the Pole Star or North Star, is a yellow-white supergiant located approximately 323 light-years away from Earth in the constellation Ursa Minor, also known as the Little Dipper. Unlike most stars, which appear to move across the sky due to Earth's rotation, Polaris remains fixed in place, a beacon of constancy in an ever-changing celestial landscape. Polaris is not a solitary star, but rather part of a complex triple star system. The primary star in this system, known as Polaris A, is orbited by two smaller companions, Polaris B and Polaris C. This intricate gravitational dance has fascinated astronomers for decades, offering insights into the dynamics of multi-star systems. However, the very interactions that hold these stars together could also be contributing to the irregularities in Polaris's behavior. The changes observed in Polaris's pulsation patterns are particularly troubling. As a Cepheid variable star, Polaris has long been known to undergo periodic cycles of brightening and dimming. These pulsations are driven by changes in the star's internal structure as it burns through its nuclear fuel. In the case of Polaris, its pulsation period, the time it takes for the star to complete one full cycle of brightening and dimming, has been gradually increasing, a phenomenon that has puzzled astronomers. For years, the pulsation period of Polaris was remarkably stable, making it a reliable cosmic yardstick for measuring distances in the universe. However, in recent decades, this period has begun to elongate, with the duration of each cycle increasing by several seconds annually. While this change may seem minuscule on the surface, it holds significant implications for the star's long-term stability. Some scientists have speculated that gravitational interactions between Polaris and its companion stars could be responsible for the observed fluctuations. These interactions may be causing subtle shifts in the star's atmospheric conditions, which in turn affect its pulsation patterns. Others, however, believe that the changes may be a sign of something far more dramatic, a precursor to a supernova explosion. The idea that Polaris could be on the verge of exploding is both exciting and terrifying. If Polaris were to go supernova, it would likely be one of the most spectacular celestial events ever witnessed by humanity. The explosion would be so bright that it could outshine the moon and remain visible in the night sky for weeks or even months. Such an event would undoubtedly captivate astronomers and stargazers around the world, offering a rare glimpse into the violent end of a star's life. However, the likelihood of Polaris undergoing a supernova explosion remains a subject of debate. While it is true that massive stars typically end their lives in supernovae, Polaris may not be massive enough to meet this fate. Instead, it is more likely that Polaris will eventually shed its outer layers and evolve into a white dwarf, a small, dense remnant that no longer undergoes nuclear fusion. If Polaris does not go supernova, its eventual transformation into a white dwarf would still mark the end of an era. The star that has served as a guiding light for centuries would fade from view, leaving a gap in the night sky that could have profound implications for both astronomy and navigation. Without Polaris as a reference point, celestial navigation systems would need to be recalibrated, and our understanding of the northern sky would be forever altered. The loss of Polaris would also have significant cultural implications. Throughout history, the North Star has held a special place in the mythology and folklore of countless civilizations. From ancient mariners who relied on its steady presence to guide their ships across uncharted waters to poets and philosophers who saw it as a symbol of constancy and guidance, Polaris has been a fixture in the human imagination. Its disappearance would be a poignant reminder of the transience of all things, even the stars. But Polaris is not the only star that has astronomers concerned. In recent years, another famous star, Betelgeuse, located in the constellation Orion, has also exhibited unusual behavior. Like Polaris, Betelgeuse is a massive star nearing the end of its life, and it too has shown irregularities in its brightness. In late 2019 and early 2020, Betelgeuse experienced a dramatic dimming event that left astronomers wondering whether it was about to explode. Although the star eventually returned to its normal brightness, the incident highlighted the unpredictable nature of stars in their twilight years. The similarities between Polaris and Betelgeuse have not gone unnoticed. Both stars belong to a class of variable stars that are prone to fluctuations in brightness as they burn through their nuclear fuel. As these stars age, their internal structures become increasingly unstable, leading to erratic pulsations and other signs of impending change. While the exact causes of these fluctuations remain a mystery, astronomers are working tirelessly to unravel the secrets of these dying stars. One of the key challenges in studying stars like Polaris and Betelgeuse is the vast distances involved. Polaris, for example, is located 323 light-years away from Earth, meaning that the light we see from it today began its journey centuries ago. If Polaris were to explode tomorrow, we would not witness the event until over 300 years later. This time delay complicates efforts to predict the star's future behavior, as we are essentially observing events that occurred in the distant past. Despite these challenges, astronomers are making significant progress in understanding the life cycles of stars. Advances in technology, including space-based observatories like the Hubble Space Telescope and the upcoming James Webb Space Telescope, are providing unprecedented views of distant stars and their behaviors. These powerful tools allow scientists to study stars in exquisite detail, offering new insights into the processes that drive stellar evolution. In addition to these observational efforts, theoretical models of stellar evolution are helping astronomers predict the fates of stars like Polaris. By simulating the internal dynamics of stars, researchers can explore how changes in temperature, pressure, and nuclear fusion rates affect a star's overall stability. These models suggest that stars like Polaris may undergo a series of dramatic changes in the final stages of their lives, including rapid expansion, mass loss, and eventual collapse. While the exact timeline for Polaris's demise remains uncertain, one thing is clear: the universe is in a constant state of flux, and the stars we see today may not be here tomorrow. As we continue to explore the cosmos, we must remain mindful of the fact that the night sky is not a static canvas but a dynamic and evolving tapestry. The potential loss of Polaris serves as a stark reminder of this reality and underscores the importance of ongoing astronomical research. The implications of Polaris's potential transformation extend far beyond the realm of science. As we observe the changes in the night sky, we are reminded of the fragility and impermanence of all things. The stars, which once seemed eternal and unchanging, are subject to the same forces of birth, growth, and decay that gove.